Hey trick guys, let's look at the section 9, 4 notes on areas of triangles. So we got two different cases where we can use these area formulas, and that's the SAS case and the SSS case. Both of them, if you recall, are the cases when we can use the law of cosines, although one of them is based on the sine function. Recall the area of a triangle can be found using the 1/2 base times height, where the base is down here and the height is perpendicular to that. So that would be what we're calling the height here. And it doesn't have to be at the bottom. Like I could have something like this, and this be the base, and if it's a right triangle, this would be the perpendicular height. It's just all about the perpendicular side. So we need to have one side that's perpendicular to the base. Like in this case, there's the base, there's that perpendicular height. So again, it doesn't necessarily have to be the bottom as the base. It's just a side length and some way to get that perpendicular height from the side length that we're calling the base. So when we are given a side angle side scenario, call this angle C, well, that means this is side C. So one of these is angle or side A and B, and so we're given SAS. So we're given the side, and the angle between them. And when that's the case, we can find the height, the area using this formula. It's just 1/2 base times height. So if we were to call, base B the base, and this is my angle right here, well, we could drop a perpendicular to base B right here. And because this is the hypotenuse of that right triangle, we can find this side length using the sine formula. So H, call this side H, the height. H is the opposite side, and A is the hypotenuse. So the sine of C is H over A. Well, that means that H equals A sine C. So if the area equals 1/2 base times height, and B is the base, then we replace H with A sine C, and you see we get that formula. So that's where this is coming from. It's just the area of a triangle formula applied to an SAS case. Now I gave the example where C was the angle that was given, but if this was C, and this was A, and this was B, and this would be angle A, this would be angle B. If I'm given angle A, then C and B would be the sides that form that. And so then I would be using this formula. So it's just all about which angle you're given and which side length you're given. Alright, so if I want to find the area of this, again, I'm going to do 1/2 base times height. Call either one of these the base. 5. That's A, right? The height is going to be B, which is 3, times the sine of C, which is 50. 5.745 square units. So again, when you're given two sides and the angle between them, then you can use that formula. Alright, when we have a side-side-side triangle, we're going to use something called Heron's formula, where we compute the semi-perimeter. So we basically add up these three values, A, B, and C. That's the perimeter of the triangle, A, B, C. So add them all up, and then once we've added them together, we divide it in half. So it would be the halfway around the entire triangle. And then we plug that value in for the S in this formula. This would be something that I would want to do on like a calculator to make sure that it would be as efficient as possible. Alright, so here's a side-side-side scenario, 5, 6, and 9. So I'm going to add 5, 6, and 9 on my calculator. Alright, and then I'm going to divide that by 2, and then I'm going to store, and I'm going to press, it's in regular mode, I'm going to press alpha, and then use S. So you can see that's above the LN, that's S. So I'm going to store that as S, okay? Alright, so now here's my area. Now I'm going to leave the radical off because they'll usually want you to simplify this and give an exact area. But I'm going to write S, alpha, S, times S minus A. That's just A, B, and C are the three side lengths. So S minus 5, S minus 6, and then parentheses S minus 9. Alright, I'm going to hit enter. Alright, that's what's underneath the radical. So I'm looking for the square root of 200. 200 can be broken down to 100 times 2, 100 being the biggest perfect square that divides 200. So square root of 100 is 10, square root of 2. So there's the exact area, but then a lot of times they'll have you approximate. about 14.14 square units. All right, that's a very straightforward, pretty easy section. Two main formulas that you got to get down. Heron's formula, all right, that two-step semi-perimeter, and then the semi-perimeter minus each side length times the semi-perimeter. I'll take the square root of that. And then the other one is based on just the area of a triangle, 1/2 base times height. It's just that the height. These are all ways to give us our height. 1/2 base times height. It just depends on the angles that we're given.